TSMC's second plant in Kumamoto, Japan is now set to produce cutting-edge 3-nanometer AI chips, some of the most advanced nodes the company will be making outside of Taiwan. What's behind the move and who's snapping at the heels of the world's top semiconductor maker? I'm Divya Gopalan and this is Connected on Taiwan Plus. With us in the studio is Simon Fang, the founding partner of Darwin Ventures, based here in Taipei. He also co-authored the Handbook of Semiconductor Manufacturing Technology and holds multiple patents in the US and Taiwan. Great to have you here in the studio, Simon.
Pleasure to be here.
Right, so let me just start with the Kumamoto plant and what's happening there. Can you tell us how significant it is that TSMC is going to be manufacturing 3-nanometer chips?
Let me put it this way, when I first came to US at 92, top 10 company, semiconductor company in the world, 6 are Japanese, 3 American, 1 European, no Samsung, no TSMC. But after 30 years, the top 20, no more Japanese. So there's a big retreat of Japanese semiconductor industry. Not just Japan really doesn't have the advanced technology. So government is trying to rebuild the capability, which is Rapidus. On the other hand, they have no manufacturing experience for basically the past 10 years. So Kumamoto effect is really significant because they can bring the talent, technology to Japan. And especially today, the geopolitical risk. Japan is very desperate to have advanced technology in Japan. So I think that announcement is very, I think a lot of colleagues in Japan are very excited about the investment decision.
And for TSMC, why Japan? Why 3 nanometer there?
Yeah, because we all know TSMC is building a big factory in Arizona. And because I would say 70% of revenue of TSMC come from U.S. governments, customers, U.S. customers. But TSMC is now facing the shortage of skilled workers. When I was born, I was close to be 60 years old. Taiwan probably have annually 400 or to 500,000 newborn a year. Today, 100,000, 1/5. Of the newborns. So we basically do not have enough people in Taiwan. So TSMC, his size has to go anywhere in the world. And basically US, Europe, and Japan, yeah.
I do want to talk about a number of points you brought up, including Rapidus, the workforce issue, and a whole number of things with the supply chain and ecosystem. But before we go do that, I'd like to learn a little bit more about you and understand your trajectory and your career path here. Now, in the early years of your career, you worked for Texas Instruments and UMC. Those two companies are very, very important in the whole semiconductor ecosystem in the early days. Can you first explain why they're considered the pillars or foundation for the semiconductor industry as we see it today?
Yeah, when I first got my PhD, I needed a job, right? And so turned out the two advanced, probably the Intel and TI are the most advanced, own the most advanced technology. So it turned out I decided to move to Dallas. I stayed there for a few years.
With Texas Instruments?
With TI. Yeah. And during the tenure of TI, I soon learned, Taiwanese industry is picking up. And so I made a decision to move back to Taiwan right away. And at that time, UMC, TSMC are head-to-head compete with each other on the foundry business. Technology-wise, they're pretty similar, it's not that behind. And until the technology node at the 0.13 micron, and UMC is behind loss. And then we start seeing the bifurcation of two companies. Mm-hmm. So I still stayed in the company for a few years. Then I decided, I think that would be very difficult for UMC to catch up. So I decided to kind of pivot to another industry, which is venture capital.
Yeah, so tell us about Darwin Ventures and why you felt like that was the next move for you, and what is it that Darwin Ventures is trying to do?
When in UMC, I actually organized an organization called New Business Development Group. That was a basic corporate venture. In 6 months, we invested 47, maybe 45, 47 fabless company, basically our customers. So that was a strategic investment. And through that experience, I kind of learned about the VC industry. And when I decided to leave the industry, either submit a resume to TSMC, to the competitor, or we're thinking about doing something totally different. So I was thinking about maybe the PC is a good business for me. I can't afford to build a factory, but I might be able to raise a fund for the investment. So that's how the company was started. And my co-founder is also the veteran of semiconductor industry. We were doing PhD together at Stanford. He started his first company and actually went IPO in the US, the computer automation for the semiconductor design. So we're all in the industry. So we started to do this. And so our early investment are still focused on semiconductor. Soon we realized it's very capital intensive. Not many early stage venture investment opportunity. So we kind of pivoted to more software, life science, and materials, all kind of industry. So that's where we are. And starting from like 4 or 5 years ago, today we have over 50% of the portfolio company are in software. But again, Taiwan, the market is so small.
Right.
So you're kind of forced to go out to look for another market. And US is very difficult because you need to raise a lot more money in order to go to US. And people talk about Southeast Asia, but Southeast Asia is very fragmented. Each country has a different legal, religion, all the systems are different. So even the market is big, and young population. But I think it's not easy for a startup company, for such a fragmented market. So turn out we think Japan might be the opportunity for us.
Right.
So we actually visited and we did a few investments, try to test the water. And then we decided to set up office at the prime location, hire Japanese people and try to grow the organization. So that's where we are today.
I want to stay with the theme of Japan, but before we do that, I want to give our audience some context on TSMC's trajectory. You mentioned when TSMC really broke through and went ahead of UMC, and I want to put that all in context in date and timeline. So I'm going to do that with a graphic here. Let's take a brief look at TSMC's milestones. The company was founded in 1987. It first relied on 2-micron and 3.5 micron chip tech from Taiwan's Industrial Technology Research Institute, or ITRI. Early on, TSMC was tasked with customizing a 3-micron process for the Dutch giant Philips. Soon, they developed their own 1.5 micron tech, and within a decade, they launched the world's first 0.18 micron low-power process in 1999. Now, between 2018 and 2022, TSMC went from 7 nanometer chips to 5 and eventually 3 nanometers. And last year, they unveiled the world's most advanced 2 nanometer or N2 technology. Can I get you to explain the latest chip, the most advanced 2 nanometer or N2 technology, and why it's only TSMC that's able to produce that?
I mean, first of all, building a factory, will cost billions of dollars, and not many companies are able to afford that, So the concept of foundry is basically adopting a standardized process, and everybody can use it. And foundry company are able to keep the customers' IP, not to leak the IP, and protect customers' IP. So when the foundry and the fabless are actually the two sides of the blade, right? They have to live with each other. And today there's no doubt because the largest company in the world, NVIDIA, is a fabless company. But back to like 40 years ago, people have serious doubt about this business model. And the best quote is Jerry Sanders, the founder of AMD. He said, "Real man has a fab, needs a fab." Basically, he thinks everybody should have a fab. Without a factory, you can't do semiconductor. So that's why Morris Chang is a pioneer in the industry. He has a vision, that make to the new the status quo of the industry today. And even Intel is a traditional IDM company, integrated, vertical integrated company, and to the very advanced technology, they can't really afford to build their own factory to compete with TSMC in advanced node. So that's why I think the whole world is moving toward to fabless, for most of our applications.
All right, so your outlook on the ongoing semiconductor race, is there anyone at all that can catch up with TSMC? Or who's the closest?
Yeah, I think the closest contender is Intel. Intel has a technology, has a product, but again, Intel's always have to struggle, how to fill their factory, right? And Intel there were numerous discussion about whether Intel should spin off the foundry group and product group, make it two companies. So product group will be a fabless company, and they can use either TSMC or their internal factory. And foundry group, because they're independent, they are able to take business, other than Intel, maybe TSMC's customers, right? And I think that will be healthy to the industry. Today, TSMC basically monopolized the business for the most advanced technology. So for the long-term development, if there's a contender be able to compete, I think that would be very healthy to the industry. So Intel is certainly the candidate.
So it's interesting that you're looking at Japan also as a venture capitalist, and we've seen TSMC give this hefty $17 billion investment into the Kumamoto plant most recently. Can you tell us why Japan? Is that seen as a natural partner for Taiwan? And what would you say would be the benefit of partnering with Japan at this point?
I mean, Japan certainly has a market, automobile, power, they do have a good technology. Also talent, has been, in terms of a Nobel Prize winner, Japan is only the country next to US. So Japan certainly has the technology and talent. So I think that'll be a very perfect match for TSMC, So I actually think TSMC will be very successful in Japan.
And from your point of view, what is your kind of outlook as far as Japan goes, and why you feel like that is where you want to focus?
Yeah, I think
Darwin Ventures.
it's an inflection point for Japan. The industry has been pretty depressed for many years, maybe 20, 30 years. But I think it's the right timing now. Everything there is reasonably priced, and good technology, good people. So that's why we think for the next 10, 20 years will be opportunity for Japan.
You earlier mentioned Rapidus, which is Japan's semiconductor endeavor, and it's backed by major companies like Toyota and a few others to name. Where are they at right now, and can they really challenge, or is the ambition to challenge Taiwan's semiconductor industry?
Yeah, they're commissioned to produce 2 nanometer. Basically, they claim they already have test chip. I have a limited information, but my understanding is, the foundry is not just about technology. It's a service industry. You got to have a lot of partners, peripheral partner to help you, for all kind of, not just semiconductor, wafer manufacturing. And that's not something Rapidus can build in years. And let's say the trend today for the industry is foundry fabless. Japan has a very limited number of fabless company. I think Japan only have like 4 or 5 fabless company went public. And their market cap combined is probably 5 to 10% of MediaTek, one of the largest fabless company. So it's tiny. The industry is very small. So Japan has missed out the major trend of the industry for the past 20 years. So that's not about you're buying technology from IBM like, to manufacture in Japan. It's about how to build a complete different ecosystem. That's something I think the Japanese industry has to learn, from the success in U.S. and Taiwan.
Now, speaking of ecosystems, the supply chains have faced quite a few challenges given, one, the U.S.-China rivalry, and then now all the geopolitical headwinds. What kind of partnership can you see forming here so that they can make these supply chains a lot more resilient?
Yeah, for the advanced technology require a lot of material development. Japan has a dominant influence in this area, and probably more influential than the equipment itself. So, for example, JSR, they have like 80% of the photoresist, the chemical in the world. So without that chemical, nobody can do anything, So Japan does have the good technology. So we're actually in talk with a lot of people from university, advanced material, try to bridge them to deal with TSMC, because TSMC will be the ultimate user for those kind of materials. And I think the industry in Taiwan and Japan are extremely complementary. Taiwan doesn't really have a branding companies. Maybe we have Acer, but it's not like Japan. Yet there are so many branding companies. So we're very complementary, and we're very good at manufacturing, and which is something Japan is missing now.
Yeah, one of the things you brought up earlier was about Taiwan's low birth rate, but it's something that Japan also faces at the moment. So, from your point of view, as you're trying to get these companies to develop, what is your advice about labor and trying to make sure that it is sustainable, especially in this in the semiconductor industry?
For skilled labor, I think AI will make a huge difference. Soon we'll realize we do not need that many people. The number of the good skilled workers is more important of the total number of the population. So that's why I think AI might be able to help the country like Korea, Taiwan, Japan, extremely low birth rate. But the issue is whether we can move quickly to kind of train all workers to have a certain skill to adopt the new AI era.
And so then when you're talking to the companies you're trying to grow, how much focus are you putting on them taking on more AI capabilities?
Everybody,
Everyone.
Yeah. If they don't have it, they'll die anyway.
Right. Japan is trying to build its own semiconductor manufacturing industry, so is Taiwan. And then you also mentioned the U.S., but again, it's a lot of investment from TSMC going into the U.S., especially in Arizona. Do you feel that the other countries that we're seeing, they have nascent industries, India's trying, Malaysia's trying, like China, of course. How far behind do you think they are in catching up with trying to supply the international community or the international businesses with semiconductors?
My tone might be a little bit passive. I don't think a lot of the emerging countries need to get into this because that would be very difficult. China might be the last country entering the semiconductor industry and under certain political environment, But today, I think because of building a modern semiconductor factory, the cost is so high, and very getting so difficult. So I was not so persuaded that every country has to build their own semiconductor industry, right? Not many countries has own automobile industry, for example. So Taiwan doesn't really have automobile industry, but we're doing well. We can drive cars, right? But not necessarily we have to build our own automobile brand, right? So that's my perspective, but some audience might not agree with that.
All right. So then what about the other supporting, and as you said, it's a whole ecosystem, the other supporting industries that are growing around the semiconductor industry? Again, from your point of view, where you are looking to grow and fund these other industries, what are the sectors you're looking at in particular? Or what kind of businesses are you looking at that can complement the semiconductor industry?
I did not focus on the mainstream manufacturing, because that's very capital intensive, but we look into a lot of material, specialty material, and basically or the packaging material, because the industry is moving so fast. every year or 2 years, they have to bring the new material, new process into to the industry. So we should be able to find something in that specific area. And TSMC is not a single company. They have over 3,000 suppliers surrounding them, make it TSMC. So without all the suppliers surrounding TSMC, they can make it, So that's why we're finding the next company into that 3,000, suppliers. So I think there's still plenty of opportunities. Looking at TSMC's capital expansion, I think this year will be like $550 billion.
Wow.
So you have small scoop of that business. That will be making a lot of startup company very profitable.
Okay, can you give us some examples of when you talk about materials, when you talk about supporting companies?
Now, one good example is our portfolio company called Ballwave. It's a spin-off company from Tohoku University. Tohoku University is the national university specializing in semiconductor. In 20, 30 years ago, Intel even need their advice to improve their DRAM yield. So it's a very prestigious research institute. And the company spin off from the university for 10 years without being able to get into the mainstream semiconductor. So we help them, advise them to find the right contact window in TSMC or in other manufacturers, So that's something we've been doing, try to bring them to the industry. Because they're researchers, so they do not really know how significant of their technology into various applications. Yeah.
You mentioned university, and I guess this is something that needs to be thought of right now because the semiconductor industry is just going to grow. Almost every single product we needs semiconductors. So what do we need to be thinking about, particularly in Taiwan, with regards to the education system and attracting more engineers? Is it engineers in particular we need? What is it that the focus should be on to keep this industry growing, perhaps here and even in Japan?
Well, Taiwan should have more foreign students, no doubt, and I think the society itself is now open enough, so that's something we're very weak, and we're so used to I think Taiwanese people are friendly because we're all immigrants, years ago from China or somewhere else. But again, as a society, I don't think they're ready to adapt people, from anywhere in the world,
Why is that important? Just because to increase labor numbers, or are we looking at innovation?
Quality labor, like when we're educated in the U.S., and nobody really care about your race and nationality. That's what Americans are great about, And 20% of startup founders in Silicon Valley are immigrants. So we don't see that in Taiwan. Mm-hmm. So I think that's something Taiwan has to improve. I started to see more and more, but not enough.
And finally, where are semiconductors heading? I mean, can it get, we went from 2 nanometer to N2 technology. So what is the next step here? Like, is there a next step here when it comes to efficiency?
I mean, the Moore's rule is a man-made rule. It's not like sun has to go from the east to the west, right? It's not. It's pushed by the man's ambition. So I mean, luckily in the past 30, 40 years, we'll be able to push that, And so basically every year we have to introduce new technology, new concept. Today the bottleneck is not just on the feature size of the transistor, mm-hmm. or the shape of a transistor. There's actually a lot of bottlenecks in the back-end packaging. So that's why we are still be able to hit that kind of performance target through all different applications. I want to give you one example. When I was taking class at 92, 93 at Stanford, the professor was telling us 0.18 micron technology is the last generation because the lithography, when the light source is very similar to the feature size of a device, we can't do anything because the light artifact will kill us. We can't do anything, and turn out we are 20 generations ahead of after the 0.18 micron technology. I think human beings are try to conquer all kind of different hurdles. You know, there might be a physical hurdle. We try to find another physical way to get around it. Right? So I'm still very positive. But of course, the industry is getting very capital intensive, and not many players are able to afford the new technology. That might be something we need to worry. You know, but.
And of the companies you're looking at, and perhaps you are hoping to develop and evolve, is there anything that's emerging as a replacement for semiconductors, or something that will really challenge the semiconductor industry right now, or we just keep going to more efficient and stick with the semiconductor chips as we know it?
I think we will, you know, but eventually quantum computing comes in. You know, there will be certain overlap. You know, so that will bring us to the next level. I hope I can predict that, but I can't. Yeah.
No, but you've already done a great job of taking a glimpse into the future and explaining and breaking down the industry as it is. So thank you so much, Simon Fang. What a pleasure to have you in our studios.
Thank you so much.